Okay, so before I start going more deep in the DCI technologies, I want to know what are your questions? Why did you vote for the session? What are you looking for?
You voted for the session because virtualization is awesome.
No, I just didn't like the other two guys. I think the use case that you presented brings more challenges with it. And I think we wanted to dig deeper, particularly into some of those challenges. And I wanted to understand the OTV a little bit more and why it's actually needed, as opposed to, how's it different from building a pseudo wire bridge or something between two places in your network?
Okay. How about LISP?
Yes, I want everybody to have LISP. I just picked it.
You understand the use cases? You understand what's supported on the platform?
I do, but I just want everybody else to, so I want you to talk about it. So I want everybody to want LISP so I can have LISP on my gear.
You want the
good high level, how it works, like a packet walkthrough on LISP would be pretty awesome. I've seen that documentation, but I know it takes a minute to wrap your brain around it.
LISP for VM mobility, and then tell them that you can run IPv6 over it as well. Gives you an IPv6 solution for an IPv4 data center is a really powerful pitch.
Okay. Yeah. So I have high-level slides. So whenever you want to go deeper, ask questions. That's how we can go deeper. But the slides themselves are kind of high-level. So when we talk about layer 2 extension, LAN extension, layer 2 VPNs, what are the protocols that we have today and how to choose between them? So mainly there are 4 protocols. We support all of them, by the way, on ASR 1000. So when we get a customer who asks for a specific protocol, we have it. It's just more of what really suits the customer needs. What are the requirements? So if you look at Ethernet over MPLS, L2TP version 3, these are point-to-point. However, they are still used. We see a lot of customers are still using L2TP version 3. VPLS and OTV. The VPLS and OTV are point-to-multipoint. VPLS is point-to-multipoint, so you actually have a pseudo wire between your data center to every other data center. OTV is a little different. It's point-to-cloud. So you don't go directly to the other end. You go to the cloud and you join some kind of multicast group. And this is what brings you together. So the benefit of point-to-cloud versus point-to-multipoint, if I'm bringing a new data center to the picture, in a VPLS scenario, I have to go to the old data centers and create a pseudo wire in every data center saying, hey, I'm up now and I can see the other guys as my neighbors. If you have 10 data centers, it's n times or 2n plus 1 or 2n minus 1. It's some equation that will give you the number of, it's a full mesh pseudo wires. So it can go really crazy. I have it in one of the slides. I don't remember the equation from my mind.
It's n times n minus 1 over 2.
Yep.
Something like that.
No one told me there'd be math here.
Math is hard.
So are you saying that the pseudo wire solution is effective if you only have 2 data centers?
Sorry?
If you know you're only going to have 2 data centers?
No, I'm saying it's not good if you're enterprise at all, whether you have 2 data centers or more.
Okay.
But it can go really to very complex scenarios if you have a lot of data centers and you want to connect them.
Okay.
That's VPLS by default, out of the box. What customers do, they have a lot of tweaks on top of VPLS, so they can actually use it. One of the tweaks is auto discovery for BGP auto discovery. You can find your neighbors faster based on range. So there are a lot of tweaks that you can do. But if you're talking about enterprise customer, usually small customers, they have data centers, but they are not expert with MPLS. They are not expert with LDP or pseudo wire signaling. They don't know how to troubleshoot that. They don't want the headache of maintaining all this number of pseudo wires. And they don't understand BGP that well. To keep tweaking it for multi-homing, for other things that work on like BGP auto discovery, the other tweaks that you have to do on top of VPLS to make it really a workable solution. If you are a service provider, it's a different case. Service providers, they have the expertise, they are familiar with MPLS and VPLS and LDP and BGP, it's a piece of cake for them. But what I have seen in my customers, for enterprise customers, they know about IP, they know how to troubleshoot an IP packet, they are not that good with MPLS, they don't want to bring it all the way to the edge of their data center.
I think there was also some Cisco history with Data Center Interconnect where some of the solutions attempted to provide you with 2 layer 2 connections, and then you start going down a very complex path very quickly. So high availability is the other challenge.
However, we see the split that some customers, especially enterprise, they go more towards OTV. Service provider, they tune more towards VPLS. So for ASR 1000, it's a box that supports both customers. We do service provider very well, we do enterprise very well as well. So here, we support both of them, and we have a roadmap for both of them. We keep investing in both features, VPLS and OTV. Couple of main differences between the two technologies. I don't think this works. The control plane versus how you learn your MAC addresses. For VPLS, it learns it in the data plane itself, so it floats everywhere. OTV, it learns the MAC addresses through ISIS, so it has a separate control plane versus the data plane. This makes a big difference in how the feature works on ASR, or even next 7K, because OTV is also supported there. So for the control plane part. So let's say you have 3 data centers, and you're gonna run ISIS between the 3 of them, but ISIS is hidden, it's part of the protocol. It's not really up to the user to configure it. We have some commands to tweak something like ISIS hello timers, if you wanna have better convergence, but in general, ISIS is not something that for the user to configure. It's part of the protocol itself.
So it functions a lot like ISIS doesn't trill, where it just runs in a black
Correct.
box, and the only thing that you have any control over is how quickly it talks to the other nodes.
Correct. And the only line that you put there that relates to ISIS is just you are saying the ISIS identifier number. So
you
each
can
one of them will
separate.
have a unique number so they can establish the neighborship without any conflicts. They know about each other. So you do the ISIS part, and then you do the regular switching part. So let's start with the first one on top here, top left. You get the packets, you do the layer 2 learning like a regular switch. You know, you look at each packet, you know where the MAC address is associated with in terms of interfaces. So you build your MAC table, as you see on the left. You just put it in ISIS packet as like a route update, and you send it over to the other peers. When you do that, you just send it to the multicast group, and it will go to all peers who participate in the same group. So it's not really point to multi-point, it's more of a point to cloud kind of connection. That's why when you insert another data center here, you just join the group or the multicast group, the cloud, and you don't have to go and reconfigure the old ones, the old data centers. The update will go to each edge device. You will decapsulate the ISIS route update, and you will install the MAC table. The only difference here under the VLAN and the MAC address, instead of pointing to local interface, you will point to the IP address where you received this MAC. So you do that, you learn your MAC table. That's the main difference between OTV and VPLS. And the next thing will just be the data plane, where you forward the traffic, you will get the MAC, and you will do MAC lookup. You will see if it points to an interface or IP address. If it points to IP address, then it has to go to the other data center. You encapsulate the packet in an OTV header, and you send it over as a regular IP packet. So it will have an IP source, IP destination, and even though that the routers in the middle of the network are not OTV aware, that they will still forward the packet as if it's a regular IP packet. So, couple of advantages here. No flooding. You only do the first time you learn about a packet, you do the broadcast, the ARP broadcast. After that, you do ARP snooping, and you know where you suppress all the ARP packets that are coming from other VMs in the same data center. You don't flood because you learn your MAC addresses already through control plane. So you have the MAC table. If you get unknown unicast, you will actually drop it. So if you get a packet with unknown MAC address, the default behavior will be to drop that packet, because you build your MAC table and you should know all the MAC addresses already. On the other data center, you just decapsulate the packet and send it to the right VM. So the VMs will look at the packet as if it's within the same data center. They are not aware of the OTV or the encapsulation part that happens on the edge.
When the multicast goes out for looking for an unknown, at the remote sites, is a local broadcast done there?
Sorry?
Is it locally flooded? Okay, so you have an origination over here.
Oh, yes,
an
yes,
unknown,
yes.
So it gets propagated to the other data centers. Does each of those data centers then do a flood within their infrastructure?
If they participate in the same bridge domain, it's going to be sent to all the interfaces that are in the same bridge domain. It will just not be sent to the overlay interface. So let's take a look at a step-by-step scenario for a VM that moves across. So you have a packet or a VM like what I showed in the demo in the previous part, just moving from one data center to another based on the OTV tunnel that you establish. When the packet moves, it's going to send the GARP. We assume that it's not a silent host. We assume that actually it's going to send traffic. So it will send the GARP. The edge router, it can be ASR 1000 or Next 7K. It will take this GARP packet. It will detect that the MAC address has moved. So what it does, it changes the metric and will send the MAC address to the other neighbors to say, hey, there is a MAC that moved, so update your local entries over here. Update them with the new location of that MAC address. Instead of pointing to a local interface, now you should point to an IP address where the MAC sits.
So is that always going to be a GR? I guess I wasn't aware of when a server did a vMotion, since the interface remained up. I wasn't aware that it actually sent a gratuitous ARP.
It does.
It does?
We
So
assume that's not silent. If it's a complete silent machine, then
if it's a,
it
yeah,
is.
yeah, but it's still talking while it's being moved. So why do we assume that it's going to send a gratuitous ARP? From an operating standpoint, it doesn't think it needs to. It's transparent to the operating system. It would be the operating system that would typically do a gratuitous ARP when an interface comes up, correct? When an IP stack comes online, it's going to do a gratuitous ARP, unless there's something built into the little VMware client to signal it to do that. I don't see a reason why the operating system would have a machine that's not been rebooted, it's just been moved, to actually send a gratuitous ARP. I would assume that this would be any outgoing packets. It would learn from the source MAC address in the layer 2 frame and do the update. So I just.
You mean for the machine that's been moved?
Yes.
But it doesn't know it's been moved, so for all, it might be, it thought it came up 5 days ago. It's sitting there not doing anything, so.
I guess that's my point.
So
But why would it be a GR? I
Doesn't
mean,
it have to update the local switches?
Yeah,
the guest operating system doesn't know it needs to update the local switches.
Who tells the operating system to issue that
It's
ARP?
not the local, it's the ESXi host that does it.
The physical host would.
Yeah, ESXi has a notify switch thing as part of the virtual
That's
switch
what I would
configuration, and
recommend.
after a vMotion, it sends a GARP out so that the switch can relearn.
Okay, so the ESXi physical host actually,
Yeah,
if sees this and it sends out a, okay.
yeah. There's a thing
That's
called.
Lots of
pretty-
functions like that in VMware that are in the same way that vSwitch never always knows what MAC address is. It doesn't need to do a MAC address discovery
Okay.
because it knows what every server is that's connected to the ports, right?
So
It knows
Okay.
what every NIC that's connected to the vSwitch is configured by VMware, so it doesn't need to discover anything, any MAC addresses, because it's either known or unknown, right?
okay.
So a normal vSwitch doesn't need to do MAC address forwarding. It knows where everything goes. It's either in the list or not. And so there's a whole bunch of things in VMware that solve these problems, like the gratuitous ARP after move, because the VMware
So-
management platform implemented move. Part of that is to do gratuitous
Okay,
ARP.
I was thinking about it from an operating system, the guest
Yes.
perspective, but that makes a lot of sense. I appreciate it.
Okay, so it's not about the VM. It's about the.
Open vSwitch does something similar for KVM platforms.
Okay.
OpenStack. for some versions of OVS, not all. So you have to, yeah, your mileage may vary.
And 1000B does that, does something similar when it detects a V version.
Yes.
So the AAD over here, which is the OTV router, is going to forward this GR to all the other AADs, so they can update their entries for that MAC address. And the AAD actually will do the same thing for the switches. Will also forward this message to the switches saying update your MAC table as well.
So, on that previous slide, when Terry asked about the multicast goes from the switch over here on the left to the two switches, or the switch on the right to the two switches on the left. But then the broadcast goes out to the rest of the network. Is that the way that would work?
Sorry, say that again.
So I think Terry asked about the multicast. Would the multicast, when it was sent, go out to the rest of the switch in the, I guess, the remote layer 2 domain?
Okay.
I guess the way I interpret it is you have this thing that's encapsulated in IP, and it's using the OTV header format that's multicast out to all the other OTV speaking switches through the cloud. And then at the other
Is this
end,
a data plane multicast, or you're talking about control plane multicast?
the data plane multicast. Is it not a data plane multicast, the OTV?
No.
You configure
OTV.
two multicast groups, one control plane, one data plane.
Okay.
This is control.
So for data plane, it's not a problem.
Okay.
Control plane.
You do the mapping. So for control plane, it's just between the AADs. They join one control multicast group for them. It's different than data plane that's coming. If you're doing a multicast server, or if you're doing a multicast packet from one of the servers over here, it doesn't overlap with the control plane multicast that's running between the AADs. It's something different.
So the
Okay.
multicast that OTV uses is for bum traffic, broadcast, unknown unicasts,
Okay.
and Ethernet multicasts, right?
Mhm.
So if you send a broadcast and you've got 4 data centers, it needs to go to the other 3, right?
Mhm.
So it's more efficient to send that into a multicast tree, and then it goes to all 3. Or you can invoke OTV in a unicast mode where it hits the edge, and then it duplicates it 3 times and transmits it 3 times.
That's the JC server feature.
Yeah,
Okay.
nobody uses the OTV multicast feature.
Okay, let me
Yeah.
get a clarification on that. Okay, so
That's
you
good.
went, well, you're doing a really good job.
Yeah.
So you had this bum request that went out.
Yeah.
Okay, it went to the other 3 data centers.
Yeah.
What then happens at each one of those data centers? Is it
Yeah.
then flooded throughout the switch infrastructure that's the layer 2 infrastructure?
Yes, so
For that?
the OTV agent, so effectively you're talking about
Yeah.
a VLAN and an OTV agent. And the bum packet comes up, the OTV
Mhm.
agent sees it and decides what to do. It'll
Makes
forward it,
Mhm.
it'll either encapsulate it in a unicast and send
Right.
it over to multipoint, right?
Right?
Or throw it into a multicast tree. The OTV agent at this side then gets the packet
Mm-hmm.
and then de-encapsulates it and says, well, what am I going to do? It says, well, I'm going to broadcast it into that VLAN.
Now, I assume that there's a shortcut that if it already knows the MAC address, goes, gosh, it's in my table,
Yeah.
then it can reply without doing the flooding. Mhm.
Exactly.
Right.
So once it's figured out and addressed, it's a much smarter conversation. It's not constantly
Right.
flooding every time.
It will do local
Sure.
acknowledgement, yes. If you turn that on.
Mhm.
Yeah, it's not, doesn't
Okay.
do it by default. It doesn't local act by default.
If you have one of these gratuitous arcs, you have to flood it at the remote site, because if the VM is broken, the switches all need to be updated to think that
Mhm.
MAC address is now out by the
Right.
OTV here.
What's your check too to make sure your IP address doesn't exist elsewhere in some cases as well?
Not always, actually. Because if you moved it from here to here, then the other VLANs don't necessarily need to know. Generally, the answer is yes, but in specific use cases, no. But the OTV agent is intelligent about that, as he'll talk about it in a minute. Sure.
You associate the MAC address with the VLAN, so you know which VLAN to broadcast and say this GR. If you look at the MAC address table in any of these routers, next 70 or ASR 1000, there is a VLAN ID associated with the MAC address, associated with the next hub, which is an interface or IP address. So you know where to send it and to limit it to that VLAN. So if you have ASR 1000 and you want to use OTV, what are the deployment models that we have? So our customers, sometimes they don't want to change anything in their network. They just want to have an OTV appliance sitting on top of Cat6K or some other switch that's sitting there that doesn't do OTV. So they are looking for ASR 1000 as an OTV appliance. So for this, it's just easier to go with the on-a-stick kind of deployment, where you have a layer 2 and a layer 3 between the router and the switch. So this switch connects to the core, and you just have ASR on a stick just for OTV appliance, as an OTV appliance. Basically, you get a layer 2 packet, you do the OTV encapsulation, you send it to the switch back, and the switch will take it to the core network. So you don't change anything in your topology. That's one deployment model. The other one is when you have ASR as a WAN aggregation or a DC edge, so it already does the other routing features and everything else that comes in the WAN profile. So in this case, you don't change anything. OTV works on top of the other features. You just expect a layer 2 packet to come from the switch to ASR 1000. So this is the trunk interface. Our use cases for ASR 1000, it's usually we see a lot of customers having a regional data center, kind of big. They get an X7K for it, and they have small data centers or disaster recovery where they need something smaller in terms of throughput, price-wise as well. So they go for ASR 1000. So we have this validated design between ASR and X7K, interoperability between our OTV implementation and their OTV implementation. Sometimes we have multiple data centers and some switches will not have OTV. So we see it a lot with Cat6K. A lot of customers, they already have Cat6K and X7K and they are not ready to upgrade Cat6K yet, or they don't want to. So OTV makes a very good fit over here to add it with Cat6K. Also, you can do just a greenfield ASR everywhere, like my demo today. We had 3 data centers and 3 of them are ASR 1000 based.
So real quick, so what compared to the 7K and the ASR, what can the ASR do that the 7K can't do from an OTV perspective?
The 2 features, actually we have a couple of features. I think they are on the roadmap for next 7K, but they are not implemented yet.
Okay.
VLAN translation is one of them.
Okay.
The layer 3 encryption. They do MACsec.
Right.
We do layer 3 encryption like IPsec, get VPN.
Well, there's no crypto function set on the 7K, right? So you're saying they're adding that?
Sorry?
There's no crypto feature set on the Nexus, right?
Yes, they don't have it today.
Right.
They don't have layer 3, they only have the MACsec.
So you're saying the only difference between the ASR and the 7K in regards to OTV is the VLAN translation and they're adding the crypto feature set?
And few things little here and there. Like fragmentation, for example, we can allow OTV packets to be fragmented.
Okay.
So we have one CLI where you can turn it on or off.
Okay.
Generally, it depends a little bit on your specific environment, but for smaller networks, implementing OTV on the Nexus is okay on a 7K, but you need to allocate a separate virtual device context just for that.
Yep.
So provided you've got spare virtual device context and you want to implement, but the challenge then is that once you implement OTV on your Nexus 7000, your code upgrades get that much more harder. Because now every time you have to do a code update, you have to check that your OTV features, as well as all your Nexus features that you're using. So all of a sudden you've lost half of the Nexus code train upgrades that you might choose to add. Make sense? The second thing is OTV can only work on certain modules. So there's F1s and M1s and F2s and M2s. OTV works on certain modules under certain conditions. And all those restrictions mean using OTV on a Nexus 7000 is not always
Problematic.
right?
Well, it can be done successfully, breaks their operational support models. It can be designed properly, except it can be designed improperly very, very easy.
Yeah.
And I think that's actually a really great point about features, or about losing access to new features, because you are absolutely dealing with 2 separate code trains. And in my opinion, the stupidest guy in your organization, the most junior, actually no, the stupidest one, sometimes they're senior. The stupidest guy in the organization should be able to troubleshoot your network at 3 AM while drunk.
Yeah.
And VDCs it's not like anyone's actually painting colors on your 7K. It's, I mean, it's absolutely, while it's innovative and it's unique to do this, and it's nice to be able to have to do this at times, stick it in extra. ASR1K gives, I mean, the slide originally had 4 choices of interconnect. Wow, I mean, I have more choices and I'm still on an extensible platform.
It depends on the use case, and it depends really on the customer. I've worked with a lot of customers when it comes to DCI. Each customer has his own requirements. It depends. When you talk about scale, about throughput, what's the core network that's running behind OTV or the edge device and data centers, there are a lot of factors that go in. Even when we talk about VDCs, sometimes we run ASR as part of the image, as part of the iOS image. My computer went down for power, so give me a second to...
Yeah, so generally it's better to put the ASR 1000. Keep in mind that the OTV licensing is $25,000 because you have to buy all of the upgrades to get to the OTV. It's not cheap. So by the time you buy 2 OTV licenses, it's actually, you're well on your way to buying an ASR router anyway.
Yeah, I'm just weighing, I mean, like, so our data center interconnect links right now, we plumb them right into the 7K, right? They're Ethernet handoffs, why wouldn't we? So the value of what you mentioned from the code proposition perspective compared to wedging another device in there, that's just another link in the path.
Yeah.
You know,
See, from my point of view,
2 of them, right?
yeah, 2 of them. From my
Right.
point of view, having a pair of ASRs over here, and so
Yeah.
every time I reboot a Nexus,
Yeah,
I don't impact my DCI link.
right.
Is a feature. That's not a bug. That's a positive value.
But you also have to remember when you're managing OTV VDC, while it may be in the same physical device, all the limitations being the same physical device, you still have to treat them like they're separate devices. They literally plug into each other,
That's right.
right?
You actually have to front patch from the
Oh, I know.
into your OTV VDC. So
So,
all you're doing is fate sharing. What you're actually doing is putting your OTV in Via or Nexus, and the whole thing shares fate. So if you need to do an update and you reboot and the VPC flaps, your DCI can flap, and then everything's dead.
so is there a similar cost to the OTV license and the ASRs as well, or not?
Well, I'm just saying, by the time you spend the 25 grand to get the advanced license and then the VDC license and then the OTV license, you're already well on your way to buying an ASR. Of course.
You're talking about 2 different, by the way, it's 2 different places in the network. Next 7K is in the data center, in the core of the data center, and ASR is on the edge. So a lot of customers, they already have ASR as a data center edge, kind of one aggregation thing. So just enabling OTV doesn't take any effort from them because the router is already there. So it depends on the use case and what you're running at that time. We don't have feature parity, but we have very close gap between the features on Next 7K and the ASR 1000. So it depends on the customer and what they plan to do. Something like adjacent server, which was the main request that come from customers, they don't want to rely on a multicast core. They want to switch to a unicast core. They actually don't want to have any dependency to the service provider. So adjacent server is about to come in ASR 1000 in 2 weeks. In this month. It's coming in 3.9, XE 3.9, so it's going to come in this month. So if you're a customer and you cannot waive the multicast core requirement, then the Next 7K will make more sense because it has the feature for a while now. So it depends. I don't have, unfortunately, like one generic answer that I can tell you how to choose which platform.
Oh, it's totally just based on the network design. Yeah, I see that.
It's based on the network design.
Yeah.
My general assumption is use an ASR for OTV if you can.
Mm-hmm.
On the Nexus if you must. It's not my first choice, it's my last choice. It's just the way I would suggest people consider it. Nothing wrong, just a good choice. Yeah.
I think the point that sounds to me like the sort of golden image debate that we used to get into with the SIP cards, and just decoupling the image and
Yes.
the feature set.
Yeah. And the ASR can also be extended, it gives you more capabilities for connecting out to service providers, because you can start to do add VPLS services or HVPLS, or an ASR has a lot more routing functionality than a Nexus does, because most of the Nexus stuff is locked into the silicon architecture of the Nexus, which is fundamentally a layer 3 router, whereas the ASR has a quantum flow processor, which is a universal munger. So if you've got deep QoS and big buffers, you can flex a lot of stuff. It's conceptually a router instead of a switch, which gives you more capabilities in that environment. So my general view is an ASR if you can, is your first choice. Fall back to something else if you must.
Do you have a feeling about the multicast aspect? Because I'm curious how many people have had the pleasure of troubleshooting multicast with a service provider.
Yeah. See, the problem, of course, is if you send multicast into a lot of service providers, they just don't support it. So the MPLS, the PEs, the PE providers, most service providers, international carriers don't allow multicast trees into their backbones, they just block them.
Or if it's MPLS, they give you a limited number of groups and then they charge per site, and it's a hefty first step. Any multicast with a site is costly.
Yeah, because it burns bandwidth on all the circuits for them, right? So they want to charge extra or they block it by default because it breaks their internal architectures.
Well, in MPLS, it's a scarce resource as well.
Yeah. It uses up TCAMs in their MPLS trees. So generally you can't use a multicast in the service. Again, running assumption, can't use multicast in your service provider backbone is the general assumption I make. And I would always implement unicast because of that. Because over time, it just makes more sense. We think of replicating unicasts as being a real problem, but we don't actually have that much bum traffic in a normal network. How many Ethernet ARPs are there per second? How many unknown unicasts do we actually spawn per second? 10 years ago, it could be, hundreds of megabytes per second. But in a modern network, we don't have broadcasts or unicasts, or there's not a lot of traffic. So the general assumption is, for me anyway, is to say OTV unicast on an ASR router. Start from there, and then do your research and see if there's any reason not to use that in your specific platform. That would be.
And the 7K M card is double the cost of an F card too. So you start looking at feature sets on the M versus F.
Yeah.
Gets pricey.
Yeah.
You got a couple ASRs right there.
Buying an M2 card just to use one, a pair of gigabit Ethernet ports gets pretty pricey.
That's a whole nother fun.
That's right. Yeah.
So unfortunately, my Mac keeps crashing whenever I do PowerPoint on slide mode, the slide view. It keeps crashing, so I'm switching laptops. Give me a minute here. Sorry for the inconvenience.
You blame Apple or blame Microsoft? It's hard to say.
Well, it actually was crashing on Apple, and I'm moving to Microsoft. Can you believe that?
Are you sure you're not using an unsupported dongle?
Mac. Oh wait.
Excuse me.
Has anyone here upgraded to Fab 2s or the Soup 2s on the 17? I haven't seen a real use to do it yet, but we don't use VDCs, so.
You need Ron Fuller to have that argument. But no, because taking my Nexuses out of service is complex. Because they're right in the middle of my data center, and if I pull out a Soup 1 for a Soup 2, I have to take them both down at the same time, which means shutting down my data center. And that's a really popular idea.
For people that need to brush up on their resume.
That's right, yeah. So, you can't even have a rational discussion around that in most sites I've worked at in the last 2 years.
So far, we've seen the Fab2s coming in with new chassis rather than.
Which is all good and fine, but you could upgrade, but in an ITIL compliant environment, your chances of shutting down your entire data center to do an update and then having very little guarantees that it's going to come back.
Sorry for the delay. I had to switch the laptops. So the next topic will be LISP, which also used in DCI, and it's used in different other use cases outside of DCI. So just a high-level explanation of what LISP is and how it works. So the main concept of LISP is separating the identity from the location. So if I log in, let's say from here, from this building, I'm getting an IP address that represents me, my computer, and also represents where I'm hooking the internet or where I'm getting, what's my location in. So if I move from one location to another, let's say I'm moving away from Cisco building and I'm going to Starbucks, the next IP address will represent my Starbucks location. It will go through a different ISP. So what we want to do here is to separate these two from each other. We don't want one IP address to represent your location and your identity. Because every time I move, my identity has to be re-established. So if I have a TCP session that's running between me and some other client, this TCP session will go down and I have to rebuild another one. The reason actually we came up with LISP, it's actually different than the mobility use case. We want to decrease the routing table in a router. And instead of sending out all these prefixes, we wanted to go from push mechanisms that the current routers do. Whenever you have a routing table, you push it to the other neighbors. We wanted to go to a pull mechanism, where whenever you need a specific route, you ask for it, like you do with DNS. You need a specific website, you just go and you do a query for that website. So it's a pull mechanism. So your router will have less number of routes because it doesn't get this all extra unnecessary routes. And also when we do encapsulation, IP and IP, and we separate the identity from the location, then you don't have to advertise every single node that you have in the system. You can only advertise one IP address that represents the whole branch or like aggregation kind of thing. So it will significantly decrease the routing table. The estimate is instead of having the 500K internet routing table today, you can go to 10K. So you save on memory, you save on power and other stuff. So it's much better, or at least that's what the original reason why we came up with LISP. But during this process of separating IP from identity, we were able to apply LISP in different use cases. And I'm going to go through some of them today. So just to tell you how it works, in today's world, when you want to know about some host, web server, Cisco.com, you just go to the DNS, you do a query, and you'll get an IP address as a reply to that query. With LISP, we're going to have a mapping server, similar to DNS. And you're going to send the identity, and you want to ask about the location. So it's the same concept. And the LISP mapping server here is really very cheap machine. It can be just Linux. It can hold millions of records with very small amount of memory, like what you do with a DNS server today. You can have a DNS server on a VM, or you can have it on a Linux machine, or you can have it on a router, and it does not take any memory resources. It's just a database, some file sitting there. So it's not a big deal. It's not heavy on the CPU. So let's take a look at the examples of identity and location. So today, we have IPv4, IPv6. These are the identity that you get. In the future, you can imagine anything. You can imagine something like a MAC address. My identity can be my MAC address, or my identity can be a barcode of some label that's sitting on a product. So if you're in a store, each piece of each product sitting on that store can have its own identity based on the barcode, and you just encapsulate in anything you want. And since you have control over the mapping server, so you can add some new attributes there. It doesn't have to be IPv4 and IPv6 like we do with DNS today. So it's much more flexible. Imagine tracking a packet, let's say something like FedEx or UPS or USPS. So you can track the packages based on RFID code, based on GPS coordinates. This can be your identity, where you are right now, or it can be your location if it's a GPS coordinate. So it's really, really flexible. Some of these are concepts, and some of them actually are implemented today. So we are going to talk more about the IPv4 and the IPv6. If you notice here, we are doing encapsulation. It's almost like IP and IP. And you can have V4 in V4, you can have V6 in V4, you can have any kind of combination you want. So the use cases that we have, that we support on ASR 1000 are 4 use cases. The first one is multi-homing. And I'm going to talk about it in the next slide a little bit more. But basically multi-homing, if you think about multi-homing, is like mobility. You are moving your machine from this service provider to another service provider, because you have 2 connections connected to 2 different service providers. So when you move the links, it's as if you are moving from one data center to another data center. It's the same concept. So multi-homing and mobility, even though that they are different use cases, but actually it's exactly the same concept, with few tweaks here and there, but it's almost the same thing. We started supporting in XE 3.3. This was a couple of years ago, so it's been more than 2, maybe 3 years. The other use case is V6 transition. I have a slide on each one of them to talk more about it, but as a high-level thing, V6, it's IP and IP, so you really have a lot of flexibility. What is the first IP? What is the second IP going to be? So it depends on your application. If the application, let's say the application want to talk in V6, but the network is still in V4, then you have a V6 for the application encapsulated in V4, and you send it out. But it's done automatically. It's not like a manual tunnel that you have to create. It's actually, the LISP router will do that for you. The VPN use case, this is the most popular use case that I see with service providers. Even though that's outside of the DCI concept, but actually it's very popular. You can connect thousands, actually millions of sites of small branches, and you can do the LISP VPN. So it scales a lot more than the current VPN technologies that we have. So if you look at something, maybe DIM VPN, it can go up to 4,000, or MPLS VPN. LISP, it's a new protocol, so actually in the LISP header itself, we put a new field called instance ID. This instance ID, it's a 24-bit, so you can have 2 power 24, you can have up to 16 million of different instance IDs. Each one of them can be its own VPN. So the number of VPNs is huge, and it allows you to connect thousands or millions of branches. So that's why a lot of either big enterprise customers or service providers interested in the VPN case. And you don't have to, if you are enterprise, you don't have to rely on the service provider. LISP is a CE functionality. You usually have it on a CE box. So you can have LISP between the CE devices over here connected to the WAN or to the hub or the aggregation point, without relying on getting an MPLS VPN from the service provider, which is going to be more expensive to you. So actually, we did a lot of studies with different customers on how much they saved on this, and there's a significant improvement going away from the service provider asking for MPLS VPN versus doing LISP VPN by yourself from the CE instead of relying on what's running on the core. And the last use case here is VM mobility. So you can do OTV on a layer 2, or you can move the VMs between different data centers on layer 3. So for, let's say you're a customer and you're moving some web VMs, web servers, or some servers that you know that they are not attached to the rest of the cluster or the old data center. So you can move it back and forth just by doing LISP without any other protocol running there. So for multi-homing, that's a typical scenario. You have your address, but it's not compatible with the service providers. So you do route pollution. And imagine if you're a service provider. Wow, okay. So what you do today, it's if you go out to enterprise customers and ask them how many multi-homing branches do you have? It's a very small number because it's a lot of effort. You have to have BGP there. It's very complicated scenario. If you want to do multi-homing, you have to have an agreement with the 2 service providers. You have to think with them of how to send the traffic. And usually when you send your address to another service provider, you miss, they cannot aggregate the addresses. They cannot do address summary or address aggregation. So you do like a route pollution to the routing table. So they charge you more. With LISP, it's very simple. You are actually hiding your identity, and you're only using your location. The identity is encapsulated in the location. So if you're going through the service provider, you are sending it out as 10.x, and if you're going through the service provider, provider B, you're sending it out as 11.x. And people will find you based on your location, so you're really you're transparent to the both service providers. So you can do multi-homing without BGP, without the complexity of it, and without paying your service provider anything extra.
Have you had any problems with reactive lookups for hosts? I assume that latency on the initial lookup isn't an issue for anybody, is it? Until it gets cached?
I mentioned that in the first session. It's about 2 extra pings. So 2 seconds the first time. The first time you're trying to reach that host or that VM, it takes about 2 seconds extra. Just 2 pings of traffic loss.
So I know you're short on time, but I have a quick question about that. I deal with video a lot. So with SIP, our big challenge is the SIP embeds the source address in the header. And you've got to have a way to either fix that up or do something. To me, this looks like it would break SIP just like normal NAT does. I mean, are there SIP use cases where you've done this? Or
It does not break SIP. This is done on the router. It's not on the same machine. So you'll take the whole packet and you just encapsulate it in another packet to send it to the next neighbor or the next router, the next LISP router, and they will do the decapsulation and they will send it back.
Okay.
So let me ask you something.
The in-station addresses don't change. It's
Yeah,
encapsulated and moved along.
if you're using SIP and in the network you have 2 routers doing GRE tunnel,
Yeah.
think of it the same way. It's just another tunneling protocol, but it's more enhanced, more intelligent. It's not
That's
GRE.
interesting.
Don't get me confused.
Yeah,
It's
okay.
not GRE. But my point is, it's just an extra tunneling protocol, but it has no effect on the end host.
We can chat on the break.
Yeah, that's fine. That makes sense. I wanted to get the concept right in my head.
If you're running 2 or more data centers, LISP is like instant DCI porn. It just solves all of the data center interconnect problems that you've got going on.
Yeah, it solves a lot of problems for me if I can do this.
Yeah. The only challenge today is that it's all Cisco and only in certain feature sets. And we'll talk offline about
Actually, we need to talk because I'm interested in the whole multi-homing thing. 'Cause
Yes.
you may have just cut the Gordian knot for me. with
Yeah,
that
but we need to talk
P6.
about it
Yeah,
as well
just
because
since
LISP
I have 2
is
minutes.
still,
Sorry,
LISP is still
Yeah, that's
launching.
I'm
And there's a
available.
lot of pushback inside of Cisco to say they're not sure if it's necessarily the future or not. And if customers could go to Cisco and say LISP is the greatest thing that ever happened, we'd actually get more people inside Cisco to commit to it, and that would be a good thing.
I think that's the greatest thing that ever happened.
One thing I want to mention,
It's the greatest thing that ever happened.
It is the greatest.
even though that most routers in Cisco have LISP today, or they have it in the very near term,
It is.
but it's not a Cisco proprietary solution. Actually, it has a lot of RFCs out there. It was internet drafts, and now there are like 6 or 7 RFCs that talk about LISP, different LISP pieces like mapping server, the V6 transition. So you'll find different RFCs. There are different implementations also. Some of them are academic, some of them are vendor specific implementation. But LISP is a standard, it's not really a Cisco proprietary thing. We are taking lead, we see that it makes change, it makes difference for many customers, it fixes a lot of problems. And actually, the cool thing about it, that the 4 use cases that I mentioned, they can be combined together. So you can have a VPN and VM mobility in the same time. You can have a V6 transition and VM mobility in the same time. So they can be combined. So it's one technology, but it can give you multiple use cases.
I want LISP in the Nexus 1000V. Yeah, but there's a counter proposal inside of Cisco not to have LISP.
They just upstreamed it in
It's called the
OBS.
CSR.
Sorry?
CSR.
CSR is what we needed in
CSR will have LISP. I think it's either coming this release or the next release on CSR. But CSR is based on iOS XE. And the ASR 1000 is iOS XE. So most of the features you're going to see it on CSR. It's just a matter of time to test it, support it, and officially support it for customers.
One of the cool things with LISP is it's actually a great DR solution. You can move, you can take an entire subnet, you can take your entire data center network and move it to a different location and just update the network. You're not updating individual servers and resources.
So most people think of vMotion, a machine from data center A to data center B, and then LISP will fix that after the vMotion. But a far more practical answer is to shut the machine off here and turn it on over here.
It's faster.
Right? And then let LISP sort it out. And then you don't need a DCI. You don't need to pay for the bandwidth here and here.
Tell those apps teams and ops teams it's more practical to shut your server down.
And so if you can take a 2-hour RTO, you shut it down here and turn it on here, and usually only take like half an hour for the storage replication to finish. So you still need storage replication, but you don't need a DCI link.
But to that point, we can always just set a load time to
It's a
live on the
very networking
GeoVM.
centric view of the world.
Well, it doesn't work.
But you'd have to wait for the map cache entry to time out in that case, because, well, that's
Yeah.
not technically
Then
LISP
how do you-
mobility,
how do you
because
mean
that
one
relies on the
servers
same
up?
MAC
They
address
had to
being
be
in both places.
When you shut down the server, it flushes
Don't
the Mac
use
cache
your app is
within
dead.
15
Yeah.
In 15 minutes.
App cache is usually 15.
Right, so you have to wait for that cycle.
For the mobility
It's
part,
easy to shut servers down. It's actually hard to bring them down.
Yeah, I mean,
I think
thanks
we're.
everyone.
I think we're at.
I know my time is up.
build active data set.
Thank you.
Thanks.